Getting here extra early for the first talk of the day. It's called AssertTrue, isDecoupled, My Tests, and I'm Dave Liddament. So the one-liner for why we're here is decoupled tests reduce the development and maintenance cost of the test suite. So hopefully by the end of this talk you'll see how decoupled tests can achieve that goal, and why is that important. If we think about the value of tests, it's essentially the cost of the bugs that are found by the tests minus the cost of the test suite. So obviously bugs have all kinds of costs. There's cost to fix it, there's reputational damage, there's all those kind of costs. But a test suite is not free either, and there's costs to write the code, the tests, and there are costs to keep it maintained. And if we can lower the cost of that test suite and lower the maintenance cost of it, then we get better value from our tests. And again, hopefully by the end of this talk, you'll see how we're going to achieve this. So that's why we're here. There's lots of great talks going on right now, so I want to make sure you're in the right room. This talk is for you. I think you've probably got to do at least some level of automated testing to get something out of it. And if you want a high-level overview of concepts that can be applied for things, predominantly we're talking about testing via the user interface and integration level tests. So that's kind of where we're operating at. We're not talking so much about unit tests today. It probably isn't for you, though, if you're an experienced tester and you're testing all the way through your software stack. And this is all quite abstract. So if you don't like abstract talks, this is probably the time to do a runner. So I'm Dave Liddament. I work for a small software consultancy called Bristol, help organise a few meetups over in the UK, and when I'm not doing tech stuff, you might see me scuba diving. That's a picture of me in the Scilly Isles a few years ago. As well, I've been working in the industry for about 15 years in various languages, and I was fortunate that probably at least about half that time I was working on projects where there was some kind of automated testing going on. And it's from those 8 years or so that I've got a few stories of things that generally I've done badly, and we'll learn from them, so hopefully you don't get the same pain points that I had. But before we start on these 3 stories, there's going to be a bit of, we've kind of discussed why this is important, and we're just going to do a bit of terminology so we're all on the same page when I use certain terms. So, on the whole, I'm pretty happy with having a test suite. Running the tests makes me feel happy. Seeing all the tests pass make me feel happy. But every once in a while, I really kind of hate my test suite. And one such time is when I make a really small change, what appears to be a small change to the functionality of whatever code I'm writing. And that small change, it's one tiny step for the requirements, but it's one giant leap for our test suite. And what happens is our tests go from all passing, we make a tiny little change, and then half the test suite fails. And there's lots of failures, and it's kind of sad face. So it's confession time now. I have written tests, that's not actually the confession. But I was near a deadline, and I made a little bit of a change, and suddenly all the tests failed, just a lot of the tests failed. And I looked at what was going on, and I thought, that's okay. It's just, there's nothing actually wrong. The functionality is fine, but the way I've written the tests, or a lot of the tests mean that this little change means I've got to go back and change every single test, and there's loads of them failing. I thought, that's all right. We're right up against it with the deadline. I will fix this later when I've got time. And my confession is that 6 months later, some of those tests still haven't been fixed, even though I said I was going to do it. In fact, I've got another confession that a year later, some of these tests that I just said skip and ignore have not been fixed. And I'm going to stop with confessions because you make me, I'm sounding really bad having tests that I've just skipped for over a year now. And of course, that's a really bad thing because those tests were there. They were there for a reason. They were there well, they're there now to protect my code against some kind of regression. And because they're not being run, that means that sometime in the future, me or another developer will change the code in such a way that if those tests were working and operating, then they would have caught whatever regression I added in. But because they're not being run, because I didn't update them when I should have done, that means those tests aren't there. That safety check isn't there. So in the future, I'm almost definitely going to introduce some kind of regression. Has anyone got tests like over a year that they've been skipped for over a year? Oh, that's good. I don't feel so bad. 2 years? No, sorry, down Miles. Okay, so just another quick bit of terminology then, coupling. So imagine we've got two objects, A and B. Coupling is the degree that these two objects know about each other. So if you have two objects and they know nothing of each other, they don't know even the existence of each other, then they're completely decoupled. So if A is our application and B is, say, our email gateway, these two things don't even know about each other. But in reality, in software, there does need to be some knowledge of each other, otherwise A cannot use B. The application cannot use the email gateway. So ideally, all that A would know about B is its interface. It would say, I just want you to send an email to this email address and here's the message. And that ideally is all that A needs to know about B, the email gateway. And how B actually goes around sending those emails, the application doesn't really care about. You know, maybe the email gateway connects via SMTP and sends some stuff. Maybe it uses some kind of third party like Spark Post or Mailgun. Maybe it puts it in a queue and it all gets dealt with later. But the point is, the application doesn't know and it doesn't care. Now imagine, for whatever reason, the application had to know more intricate details about how emails were sent. Maybe it needs to know the transport mechanism. Maybe it needed to know some credentials or something like that. The problem is, now the application knows a lot more about the email gateway than it really needs to. And if we make a little change over there to the email gateway, then maybe we also have to make a change to the application as well. And maybe things are coupled to the application. So maybe one little change over there could ripple through our entire code base. So we want to have things as loosely coupled as possible. And when here the application needs to know about the internal workings of the email gateway, they're becoming more tightly coupled, and generally that's a bad thing. Or as a very silly example, it's a bit like junk food. The less you know about what's going on inside it, the better. So, one of the benefits about having loosely coupled code is it's very easy to have alternative implementations of something. So imagine in this case, A is our application and B is our payment gateway, and we want to run tests. Now imagine if we had to use a real payment gateway every time we run our test suite. It could get pretty expensive just to run the test suites with all the payments we have to make. So that's ridiculous. We wouldn't really use a real payment gateway in most of our testing, unless we're specifically testing that payment gateway. So if our code, so what we really want to do in tests is we want to replace something that looks just like B. It's not a real implementation, it's a test double. It behaves the same, well, to the outside world, to aid the application, it behaves the same, but in reality, it does something different. So the more loosely coupled these two things are, the easier it is to provide an alternative implementation for, in this case, our payment gateway. And then again, the final bit of terminology is the test pyramid. And it's kind of a way about thinking of the different levels of testing that we might do on our software. So the top of it is the UI. That doesn't mean we're testing the UI. It means we're testing our application via the user interface. So that's, although it says UI, you might be doing elements of UI testing as unit tests. So for example, if you had something in an Angular app that converted a number into a currency, you might actually unit test that bit of code. So when I talk about UI testing today, I'm talking about testing the application using the user interface as an entry point to testing it. As a general rule, unit tests are, relative to testing by the user interface, are quick to write, fast to run, and cheap to maintain. And as you kind of go up that pyramid, the tests get slower to run, they're more effort to write, and they kind of involve more and more bits of the system. So ideally, we want to maximize the number of unit tests, but then you still have to make sure that all the unit tests are working correctly together. So that's why you've got your integration tests, and then you need to make sure that your user interface is attached correctly to the software you're running, so that's why you do some tests via the user interface. So that's enough terminology for now. As a reminder, this is why we're here, and let's go on to the first story. So my first story is about an application I wrote, and what it was kind of a quiz application. So it was for a company, and all their employees went online and they answered these quizzes, and every couple of months a new quiz would come out. It was generally all a bit of fun, but there were prizes for the best performing team and the best performing individual, and employees would move every so often from one team to the other, and the team, when you took one of these quizzes, your score should be allocated to the team that you were a member of at the time you took that quiz. And as I say, it's all a bit of fun, nothing too serious. But, so I wrote all this code, and what would happen, typical user story, would be something like Bob would log in, Bob would see a list of the quizzes, he'd pick one he hadn't done, and then he would complete the quiz, he would see his score, and his team score would be updated. So very simply, that's kind of what would happen. So initially, all my testing was manual, and it was done by the user interface. So I'd log onto the site, I'd click in, I'd do this kind of stuff. And it wasn't long before this was a pretty painfully slow way of testing. So I had to automate it. And initially, I would use a tool like Selenium, and I'd write these scripts, and the scripts would kind of look a bit like this. It'd be things like visit the home page, find a login link, click on the link, find the element, and so on and so on and so on. And there's a number of problems with tests like this. First, it's not really even clear what this is doing. This would be a really long test, and it wouldn't really be obvious from reading it what's actually going on. And the other thing is the tests are really fragile. So if we made one change to any of these steps, and potentially loads of our tests would fail. So someone might come along and they say, we've just got this tiny little request. Can we change the layout of the page that shows the list of quizzes? This is a perfectly reasonable request to be made. But the problem is, if I go and make that change, and maybe I change the ID of an element somewhere on the form, then suddenly all my passing tests go back to this. They start all failing. And this kind of comes back to the confession. If you're kind of up against it, you might look at it and you go, well, I know fundamentally I haven't changed any of the functionality, so for now I will leave all those failing tests, or I'll skip them, or I'll ignore them, and I will come back and fix them. And as we know, people never come back and fix them. And you can kind of see why, if you've got fragile tests, it leads to essentially bad practices. So why are these things so fragile? Arguably, if we're testing via the user interface, in terms of decoupling, it could be seen as quite good, because we've completely decoupled what we're testing from the implementation detail. We could take it, the application, we could rewrite it in a completely different language, and as long as all those tests pass, we know that we have the same behavior for the things we've tested. However, the problem with coupling our tests to the user interface is that generally a user interface is the least stable part of a software system, and there will always be tiny little changes that we're making, which then will lead all our tests to fail. So essentially what we've really done is we've coupled ourselves quite tightly to the user interface of our software we want to test, which means our tests are pretty fragile. And tiny little changes to our software on the test can cause lots of our tests to fail. So I thought, clearly I'm not doing the right thing, and pretty much every problem in software has already been solved, so I did some reading around. And one way of solving this problem was something called a page object. So a page object sits between the test and the software under test. And on one side, we're kind of talking more in the language of what we're trying to achieve, like we're trying to log in, we're trying to answer a question. And that's the kind of conversation that the test has with the page object. But the page object then talks more in the kind of conversation of I'm clicking on this link, I'm trying to find this element by name, and I'm doing this click. So what you'd have here is the test would say, I want to log in as this username and password, and the page element would find the relevant elements on the, find the relevant bit of the form, and it would put in the username, the password, and click submit. So a page object would kind of simulate the actions a human would do if interacting with this website. So it could do things like populate a form, like the login form. It could pull data off the page, and it could navigate to another page. And a page object might not map one-to-one with like a page on the internet, on the web application. It might be a fragment of a page that you would view when you're looking at the page. So we've kind of reduced the coupling between the tests and the software under test, because we've got this intermediate object, the page object in between. And it means if we make a tiny little change to our software under test, we just need to update the page object, which talks from the page object to the software under test, and our test code remains the same. So basically, our page object is isolating changes with the user interface of the software under test. And you can't, if there was only one test interacting with this, then it probably wouldn't be worth it. But in reality, there's going to be lots of tests doing the same kind of interaction. So that's where the value comes in a page object. And now our tests kind of look a bit more like this. We are going to the home page, we're getting the login page. From the login page, we're going to try and log in, then we're going to find the quiz we're interested in, then we're going to give a load of answers, then we're going to submit them, and then we're going to check the score. So this, hopefully we can see, is going to be less fragile, but it's still not apparent really what we're testing here. You know, the test we're really asking is, does an individual score get correctly allocated to their team? That's what we're trying to do. And even looking back at that test, it's not really obvious from reading through that is what we're trying to achieve. Or if it is, you've got to kind of spend a lot of time reading that test. And also, someone might want to come along and say, we've just got this tiny little request. Can we change the page a user gets to after logging in? So originally, they were shown, say, a list of all the quizzes, and now they're going to be taken somewhere different. Again, a completely reasonable request to be made. But if we look at our tests, then all of a sudden, after we log in, we assume we're getting a My Quizzes page, but actually we're going somewhere else. So we have the same problem again, that we've made what is essentially a tiny little change. We've made no change to the business logic of the application, and all our tests are failing. So again, we can kind of approach, we can basically do the same thing. Again, we can have now an extra layer between the tests and the page objects, which could be like a domain-specific language layer. And this kind of talks in the language, it provides an interface to the tests which are more in the language of the business that we're trying to solve. So we're talking more about things like, I want you to submit answers, I want to get a team score. And the DSL layer knows that if it needs to submit answers, it needs to go off and talk to this page object, go to the answers page, and then another page object to pull the answers back, and then it can just return them all to the test. So now, our tests look a bit more like this. We're assigning a user to a team, so we're assigning Bob to Team Apple. We're submitting Bob's user scores for quiz 1, and we're saying for engagement he said A, for enjoyment he said B. These are multiple choice things. and then we're getting the score for Team Apple, and then we can say we expect the score to be 7. So this is a lot closer now to, if this is what we want to test, does an individual score get correctly allocated to the team? We can read the test and see that actually it really is testing that. So not only are our tests more clear to understand, they're also a lot less fragile than they were before. And I've kind of highlighted the bits in green. I don't know how easy that is to show up, but assign users to a team, that's kind of a lot closer to the business discussions that we might be having. So submit users' answers. So these are a lot closer to whatever problem we're trying to solve. So this essentially is what we've done. And I've got 2 layers here. It might not always be 2 layers, but it's kind of, what I'm saying is we need to kind of separate things out a bit and think about like all the good principles we would do if we're developing software, but apply them to tests. So if we're thinking about things like single responsibility principle, the page objects is their responsibility to interact with just sections of the software and the test. And they're talking in the language of, I'm clicking on this link, I'm clicking on this link, I'm inserting something into this form element. Whereas you've then got a more abstract layer, the DSL layer, and that might be talking about things like, I am submitting scores for user, I'm getting a team score, and then your tests are talking more in the language of a business, of whatever business requirements we are trying to solve. And the important thing here is that the tests, in this case, should only change if a business requirement changes. So that's the only time that our test should change, because we fundamentally changed some business logic. Now, when I first started doing this stuff, it was a long time ago, and in reality now, a lot of what we write doesn't really necessarily interface with like HTML elements on a page. Maybe we're talking more to like APIs. Maybe we've got a system and its kind of boundaries are it gets information from a queue. People put something on a queue and it pulls that information off, and then it provides information to users via a web interface. So actually, we might not always be having page objects that are talking directly, making HTTP requests. Maybe, like the red thing here, we're talking to the system in some other way. So if you work out what the boundary is of your software under test and work out all the ways something can interact with it, it might not necessarily these days always be over HTTP. So what do we learn from story 1? Testing an application's business logic via the user interface is quite difficult, it's time-consuming, and it requires a lot of effort. I think that's probably fair to say. Now, if we introduce layers between the software under test, then we're kind of, in a way, reducing our coupling between the test and the software that we're testing. And we are isolating changes. So if anything changes, we just got to go and change one thing in the correct layer, and then suddenly our test will work. And the tests do not change unless the functionality, unless the business requirements of the software under test change. And not really relevant to you, but I don't really like doing this kind of testing, and I've largely moved away from it because it's quite painful. So this is our aim, to reduce the coupling of our test suites, and hopefully you've seen that if we've done what I've just discussed, we're going to achieve that goal. And you might say, well, isn't that a lot of effort to create all of these extra layers between our software and our software under test? But this essentially is going to be code that we'd have to write anyway, and we're just doing it in a sensible place. So I think you would find on any non-trivial example, it is probably quicker to write your code in this way. But that's story 1. We've got 2 more stories to go, so we kind of need some kind of cliffhanger to keep us all excited, ready for story 2. What happens if we replaced our entire website with something else, like an app? Or what happens if we we'd written it all as ages ago, and we went from Web 1 to Web 2.0, or then we went from web to the app, or now we're at a progressive web application, or now we're going to go from that to some serverless thing. Suddenly, all our tests would no longer be relevant because they are specific to just that particular interface. And we're going to find out how we can get around, how we can potentially solve that problem. And the other kind of thing, it does feel like a lot of effort what we've done there, just to test the business logic. So, story 2, my journey through testing continued. And I was pretty sure that what we'd done on that first story, it was better than doing no automated testing. It was a step in the right direction. But I couldn't help feeling that it was a lot of effort, and there must be a kind of a better way. So what happened there was, we'll just pretend, I actually went on to work for a different project, but we'll just pretend for this one that we had to make some changes to our application, and then let's say you had to pay to start doing the quizzes, and you also received an email every time you completed the quiz. So you get the team's current running total. So previously, I kind of treated the software like a black box, or in this diagram, a big purple circle. And I didn't know anything that was going on the inside. The only way I could interface to it was either via the user interface, and in the case of this new functionality, we have an email gateway and a payment gateway. And if really my software was a big black box, there is no other way of testing it other than via its external interfaces. But I kind of thought there must be a better way, and I did some more reading around it, and there's these kind of two things, layered architecture and hexagonal architecture. Now, I haven't got time to go into the details of this, but we'll just pull out the principles that are most relevant here. So, if we could organise our code slightly differently, we might make testing a lot easier. So in the centre we've got the business logic, and this is the code that's actually specific to whatever problem we're trying to solve, and that's the kind of high-value stuff that I'm really interested in testing. I mean, the other bits you do need to test, but the business logic is what I'm really, really interested in testing. And then around the business logic, we've got this kind of green thing here, which is the service layer, which is an interface to the business logic. And then we've got the framework, which it all sits inside, and then we've got the outside world. And the deal is, anything on the inner circles know nothing about the outer circles. So the business logic has no idea that it is part of, in this case, a web application. But the outer layers can know about the inner layers. So what would a service layer look like? A service layer is just a very thin layer to the business logic. So we might have an answer submission service where you can use it to submit a user's answers. So you say, here's the user, this is the quiz ID, and then there's an array of answers. So it's the job of the controller in this case to pull out the information from the request and then give that over to the service layer via a nice interface like this. Now, the service layer is quite a thin layer, and how the business logic actually goes around implementing that, we don't know and we don't care. Maybe it's some CRUD application, maybe it sends off a load of events and commands. It doesn't really matter. That's all implementation detail that we don't really care about. Now, testing is full of compromises, because if we kind of go down this approach, now we are kind of coupling our tests to the language we've chosen to write our application in. So that means we have coupled ourselves to a programming language, and we are coupling ourselves to this service layer. However, the service layer is still pretty abstract, and it's better, really, than coupling ourselves to the user interface for driving our tests. So essentially, on test pyramid, we're now doing a lot of testing here at the integration level. So that's great, but there's one kind of question you might say. If the inner layer knows nothing about the outer layer, how on earth can the business logic do something like send an email or talk to the payment gateway. So the business logic is aware of the interfaces to these things. So it will have an interface to the email gateway. It knows about the interface to the email gateway or the interface to the payment gateway. So the email gateway might look something like this, and it's just got a single method, which is send email. Who's it to, who's it from, subject, all that kind of stuff. And what would happen is the real implementations would be injected in, probably via the dependency injection bit of the framework. And then you have adapters, and they actually know how to talk to the payment gateway or the email gateway or whatever external service it is. So testing becomes a lot easier because what we can do now is we can replace all the external real implementations with things that we use for testing. So, for example, we could have an email gateway spy, and its job, it has the same interface to the email gateway, so the business logic doesn't know if it's talking to a real email gateway or a test double. So obviously our email gateway spy has to comply with the same interface. So it's got this method here, the send email, but instead of actually sending email, let's just say it stores all that information in an array, and then we provide an extra method which is a way of retrieving all the emails that would have been sent during the test. And then that can be used by our test script later. So testing kind of becomes a lot easier because we've got our test, we might have a layer in between that and the service layer, but actually probably the language of the test and the language of the service layer are pretty similar. So in our test we might say I want to submit a user's answers, and the DSL might be saying I want to call the submit the user's answers. There might even be no need to have that layer in between when we're operating at this level. So the service layer will be generally far more stable than when we're testing via the user interface. So we've got our application that looks a bit like this. The outside world's talking to it via a controller. We've got the business logic, and it's got the various payment gateway and email gateway to talk to the outside world. And when we're testing, we can replace the outside world with test doubles, and our test entry point goes and talks straight to the business logic via the service layer. And if we compare how much easier that is than what we had previously, when our test entry point was kind of having to talk to controller, then, I mean, that would be really difficult to work with. You'd have to do things like, work out what form you're clicking on and where you're putting all that information. Whereas now, if you're talking directly to the business logic, it's much easier. And we didn't even address how we're going to check that the emails are sent or how we're going to check payments are made when we're using the real implementations. So this is all great, but it does mean you have to architect your code in this way from the start. And that's fine on greenfield projects, because now we all know how to do this. But if our project kind of looks like this and it's all just one big blob of software, what realistically can we do? And the answer is it's quite a slow, painful process. There's no silver bullet here, really. But if I was presented with software like this, then the first thing I would try and do is say, right, I'm going to take one of the external things we're talking to, say the email gateway, the payment gateway. I'm going to create an adapter that talks to that and provide a simple interface to it, and then pull out all the code that talks to the payment gateway, put it in the adapter, provide an interface, and then make sure all of the code that was originally talking to the payment gateway is now doing it via this adapter. I do the same for any other external services. And then the other side is, okay, I've got the controller. I need to make sure that our controllers have no business logic in. So I'd be pushing the business logic into the center. So then I've got all the business logic pushing into the blue circle in the middle. And then finally, I would go around and say, right, let's create a service layer for this. And then we're where we need to be so we can do our testing. So if we do most of our testing by the integration level, do we still need to test via the user interface? And we do, because we need to, the question we're then asking is not does our code work? We're saying, have we correctly wired our user interface to our business logic? So that test space is much smaller, which is good. So if we look at all of the tests we're running at the user interface level, what we could do is we could pick a few and go, right, actually that kind of covers, these couple here, they cover most of the interactions between the user interface and the service layer. So we could just say, well, I'm just going to pick those two out and kind of rewrite them to interact with the tool via the user interface. And then you've kind of got to take a view as to whether that's worth automating, because we've reduced our test base so much, maybe we don't necessarily have to automate it. You've kind of got to think, what is the effort required to automate these tests? Is it just cheaper to pay someone to do it manually? And that depends on lots of things. How difficult will it be to write automated tests that are testing via the user interface? How often does the user interface change? And that's a question I can't answer. It's just, on a per project basis. I definitely automate all the testing at integration level, but whether we automate some of the other stuff is kind of, you just got to take a business call on that. So the moral of our second story is testing the application logic at the integration level is far easier. Because we are introducing coupling between our software under test and the service layer, but this is still relatively abstract. So I think it's a much better place to do that kind of testing. But we still do need to do some testing at the user interface level. But if we are going to do this, we do need to architect our code in a way that makes this testing easier. But you'll probably find if you architect your code in that way, there'll be many other benefits as well. Like, for example, if we changed our email gateway, we can just go and code up the new email gateway adapter, and everything else just remains the same. And again, not really relevant to you, but I quite like doing this kind of testing. So there we go. So remember our cliffhangers from story one. What would happen if we replaced our entire website with an application, with an app? Well, in this case, if we'd done all our testing like this with the business logic, it wouldn't really matter. Sure, we'd have to throw away the tests that were testing our application via the user interface, but they're not there to test the business logic. They're there to test that the user interface is correctly wired up. And if we come along with an app, then we don't need to write a load of tests for the app that then test the business logic. We just need to write tests to make sure the app is correctly connected to our business logic. And because it's a completely new interface, we'd have to write those tests anyway. And remember, I thought the way of testing via the user interface was a lot of effort. If we do it this way, it's definitely a lot less effort. So hopefully we can see we've kind of decoupled our tests a bit more, and we are reducing the cost and the maintenance of a test suite. However, I still had this nagging feeling that parts of my test suite were still more tightly coupled to the software that I'm testing. And that's what we explore in story 3. So, I'm far happier with how we're doing things. I think we've got quite a good test suite. But there are still areas where I think maybe what I'm doing is I am too tightly coupling my test code to the software under test. So let's imagine that our software is doing really well and we're going to release it to more companies. And each company basically has their own branded subdomain, which they can go to. And when they log in, you can only log in from your company's subdomain. So basically, whereas before we had to provide a username and password, now we're kind of doing username, password, and subdomain. And only if all those three work, then you're successfully authenticated. So I made the changes to the code. I mean, again, I'm taking a story from another project I did and making it fit this project I'm talking about, just so we don't have to introduce a new project. But this is kind of a real thing that did happen. And I ran a load of tests, and all of a sudden, loads of tests failed again. And I kind of was looking at this, why on earth does a test that's doing this, does an individual score get correctly allocated to their team, why should that suddenly fail when we've changed how we authenticate users? I mean, it shouldn't. This is talking nothing about authenticating users. And this code had been stable for months. There's no reason for it to suddenly fail, as far as I could see. And it was all to do with really how I was seeding the data. So at integration level, often you are, at the start of your test, putting data into your database, your data repository, to get something into a state ready to do run your tests. And the way I was doing this, how I was seeding a database, wasn't particularly sensible. So I was using a tool, and it would look through a YAML file, and it would look at like the outer level and go, right, I'm populating the users table, and then it would create some SQL insert statements based on this information. So it would say I'm inserting with name Anna, email Anna@me.com, and so on. And it would generate all the SQL and just inject it directly into the database. And this is not a great way of doing things, because what happens if something changes? Like, there was narrow requirements that each user belonged to a company. The company ID had a not null constraint because every user had to belong to a company. And then I had to go through all of these and just add in the extra thing to say which company they belong to. And that's why suddenly we had loads of tests working to loads of tests failing, even though the business requirement we were testing remained unchanged. So if we do things like this and we put data directly into a database, this isn't great. We're coupling implementation detail. Like at integration level, we shouldn't really care how our data is being stored. So we're having unnecessarily coupling between our software and the test and the software under test. And also at test level, we might not really be using real database anyway. So the database, I think, belongs outside of the business logic. It's just implementation detail. It's just something else, like an email gateway. And sometimes in testing, for speed purposes, I might not use a real database. I might use a fake database. And if our tests are putting data directly into a real database, well, it means I can't replace the real database with a fake implementation. So there are a few methods we can get around this. How are we going to build our fixtures? So we've kind of looked at what is wrong with seeding directly from a file into the database. So we could hand build the objects, or we could use some kind of builder pattern or factory pattern like the object mother or the test builder. So I could say every time I need a particular object, I'll just go and create it by hand. And this is fine if I only ever do this once, but in reality there's going to be loads of times in my test where I need to register a new user. So this definitely breaks the don't repeat yourself principle. And obviously every time we make a new requirement for something like now a user belongs to a company, I'd have to go through the entire test suite and basically make that one-line change. So we don't really want to be hand-building anything, and certainly if we're going to make it more than once. So another thing we could do is use this pattern called the object mother. And it's just a factory. It's just a way of building an object in a known state ready for testing. So we could have a user object mother, and the responsibility of the user object mother is just to build users, test users. And if you use like user stories and you have personas, then what you could actually do is, let's say in our user stories, Anna has a persona, and that means something. Maybe Anna's the administrator and Bob's a normal user, and so on and so forth. So we could actually just say user object, get Anna, and it will create a user who has all the properties of Anna, and then everyone knows what that means. So our function essentially just wraps the code that we already had. It checks if the user already exists, it just returns it. Otherwise it builds a new user using however we create users. And the good thing about this is if we do need to make a change, like we have to now add the user's company in, there's one place where we need to make that change. And another way of building things is use the builder pattern, so we can have a user builder, and if you call build, it just builds a user with a whole set of default values. But the other thing you can do in the user builder pattern is you can just override anything you want to. So you can say, build me user, but instead of calling it Anna, call her Annabelle. Give her a different password, put her in a different team. And if we start going down these patterns, then actually what we'll probably find is we've got relatively complex object maps or object graphs even. So you might find that one object mother defers to another. So in this case, for the user object mother, when we've added this requirement that a user now belongs to a company, we might say in the method that creates a user, we might say, I'm going to delegate off to a company object mother to go and create the company that user belongs to. And the company object mother code will look just like the same. So it'll say, have we already created Acme company? No, we haven't. I'll go and create it. Otherwise, I'll just return that company that's already created. So then you kind of could come back to, if you do want to populate everything through like YAML files, then you can kind of have some hybrid approach. So you could read through the YAML files, and instead of putting it directly into the database, you could then build the objects via one of the data builder or object mother type ways of doing things. And then we've kind of decoupled how we create users. So you just say, I want to create a user, and then we've got some code somewhere that knows how to create a user, and if we change anything about how we create a user, then none of the tests need care about that. They just say, all right, I want a new user, and then the code just goes and builds a new user in a valid state. So hopefully we can kind of see the benefit of that. So the moral of story 3 was use patterns like object mother or test builders, or essentially just have a single place where you build some of these complex objects for your tests. That's the key thing. It makes our tests more robust to change, and also it allows us to do things like use fake in-memory databases rather than real ones. So often I use the repository pattern for persisting data. So if I run tests, and sometimes a test might take half a second or a second to run when using a real database, but if I provided like a test double, a fake implementation of that repository which just stores everything in memory, in arrays, then you could do hundreds of tests in that half a second or a second. So we're basically doing more to decouple our tests from our software and the test. So this essentially is why we're here, and we've kind of had 3 stories, and hopefully you've seen how what we've done is we've reduced the coupling between our tests and our software and the tests, and hopefully we've all seen the benefits of that. So it's all about decoupling. In summary, we're just decoupling here. If we are going to test via the user interface, remember to have layers in between so we can isolate changes. Ideally, though, we probably want to do most of our testing of the business logic at the integration level or even below. And when we're doing that, we need to make sure we design our code in such a way that it's really easy to replace real implementations of external services with test doubles. When we're building data, don't put it directly into the database. Put it in via some kind of build method or have some build pattern or something like that, which decouples things like the implementation detail, like our database schema, from our tests. And remember, really do the right level of testing at the right area of the right part of the test pyramid. We've not really discussed anything at unit test level today. That's kind of a whole talk on its own. Obviously, we want to do most of the testing we can further down the pyramid, but you do have to do these higher level tests. So that's our summary. Essentially, decoupling is good. Just like it is when we're writing real code, it's equally applicable to testing. because it's basically reducing our development and maintenance costs of the test suite. Remember to do things at the right level, and yeah, it's all about architecting the code correctly. So that's basically a summary of what we've discussed. Thanks for making it to the hangover slots. I'm Dave Liddament. Thank you for listening. Any questions? Yes?
What are you testing when you use an in-memory database instead of the real database?
So, if I'm using in-memory one, if I consider that all my interactions, so commonly I'll use the repository pattern. So the repository pattern would say, get me a list of, I don't know, users for team Apple or whatever. And then it would return a list of users that meet that requirement. So my business logic probably doesn't really care how that data is stored. It's just saying, I don't really care how you get me all the team members for Team Apple. I just want all those team members. So that's why I think that the database is just implementation detail.
So you are testing the business logic?
I'm testing the business logic, yeah. However, what you still need to do is you still need to test that your approximation of the database and your basically your test double and the real implementation function in the same way.
My question is that if you're testing the business logic
Yeah.
at the integration level, why are you not testing it at the unit test level?
Okay, so you would want to push as much down as possible to the unit test level, but sometimes so for example, in this particular project, there would be things I would be testing at the unit level. So for example, have I correctly calculated the score of a particular quiz? So what would happen in this case is the quiz typically had like 10 questions, and each question had a different maximum score. So I would, at a unit test level, say, okay, if these are the questions and these are the answers applied, what is the total score? I would definitely do that at unit test level. But then the bigger question of, have I correctly pulled out all the information and worked out all of the team's current score based on all the times when the tests were completed by which user. I know each of my individual components work, but how do I know that I've joined them together correctly? So that's kind of that's the question I'm answering there, is I know all the little bits work, have I joined them together? In the same way when you're writing PHP code, you just assume that all of the PHP functions you call, you just assume they work. And the whole point of unit test is, have I joined all those things together at the unit level? Well, it's the same thing, but just a level higher.
But basically what you also could do is have kind of not a service layer, but a business logic layer where you have high-level business processes. And this is what you are talking about. You're using multiple components to produce a total test score or whatever. And then you would test those at the unit test level as well.
Yeah, so I would test like the intricate details of whether it's adding a score up at the unit test level, but then I'm just saying, are all these things working correctly?
You have a data access layer, and you just use a double for that, so you don't even need an in-memory database. You're just returning some fake values anyway. So the test double I might be doing might be, so if the integration level is a quite high level one, it might be saying, create me a team, put these users on, create me two teams, put me this user in this team, make them answer this quiz, now move them to another team, make that user answer that second quiz, and make sure that the scores have been associated or allocated to each of the teams correctly. So in this particular example, there was no single unit bit of code that did that. It required lots of moving parts of the system to do that. Now, the database, that's just a data persistence thing. I don't really care how that's persisted. I would do tests with a real database because
I still need to make sure that my approximation of the database is correct, because obviously if my database test double and the real database do not behave in the same way, then it doesn't matter that it all works with my test double, because I don't know that it works with the real database. So a way that I might take these two things is I might have a simple test that says I am going to create a few users, allocate to this team, persist them, and then I'm going to pull out, or I probably have a couple of users for different teams, and then I'm going to pull out all the users. So I'll call get users for team A, get users for team B. Then what I can do is I can have a test, and I run it once with my test double and once with the real implementation. And if that passes, then it says to me, it gives me confidence that my test double is a good approximation of my real implementation of the database. And then it gives me more reason to believe that my test double is fine to use when I'm testing the business logic. Now, the times I would only really go to do that is when the tests are getting too slow. So, like, we have one test suite that takes like 30 or 40 minutes to run, and one of the reasons is because it's using real database, and that could be an order of magnitude quicker. Well, it'd probably be probably going under a minute if we had, test double.
Yeah,
so
that's why I would advocate doing as much as you can on the unit test level.
Yeah.
And then if the integration test with the real database runs like 20, 30 minutes, I would do that when someone checks in code to the and then my Jenkins job runs.
Yeah. I mean, we have a CI that does it, but 20, 30 minutes is just a bit too slow.
That's
yeah.
very long, but
yeah.
for a huge system, maybe you have to split it into smaller systems.
Yeah, it's just, I'd only ever go to the fake databases if speed is an issue. Yeah, but I mean, absolutely, you want to push everything down.
In-memory database, but the problem was, what I found myself doing is all the time trying to use my real database in a way that it would also work with the in-memory database, meaning that I would stick to the SQL standard very closely, which is a good thing in itself, probably, but once you start using your database, if you use, for example, a spatial database that does some calculations, does this country overlap with another country, how many cities are in, if you start using real database function, then it does not make any sense anymore to try to do this with a fake database. So
when I say fake, I'm probably talking at a high level of abstraction. I'm saying if you've got a repository interface, generally that's the level where I don't have a MySQL and a SQLite. I might have a MySQL implementation of the repository, and then I might have a PHP array implementation of the repository. Although when you start doing things like the spatial stuff, then I mean it would take too long to probably the database is quicker anyway.
So I think the thing there would be to do it with static data. So that your fake database is just returning a fixed example.
But then and that is appropriate, I think, for some times. But then you've still got, you're quite tightly coupled then, because you need to know exactly what order the data is going to be coming in and what you're returning. So I think that would be. We're going to have more of a chat later. We've come to technical. Has anyone else got a quick question before? No? Yes.
What are your favourite tools in each of these layers?
I'm a bit of a dinosaur and still use PHP unit pretty much as a test runner for everything. I do think, though, that BHAT will offer a lot of benefits. But I think that the principles are applicable, I think, to everything. It doesn't really matter what tools you use. But I do generally think that, certainly for higher up the thing, I would be better off. I'd have a less painful time if I used BHAT, just because it abstracts away some of this stuff. Yeah.
In our company, we also write a lot of different level tests. And what we have on the integration and integration test level is that, for example, exactly with your example, the gather user.
Yeah.
And our user is a bit more complicated. For example, you check the membership.
Yeah.
And then a lot of tests implicitly use that user. And then if we one test, we change the membership, and then a lot of other tests is broken. And then what we actually want is that, like, probably we can really easy segregate some tests to say, okay, one set of picture, another is a different set of picture. All of that, at least we didn't know a good approach. So, do you have any insight on this?
Sorry, so the question is, you've got...
What we have is that we got the user, like the mother object.
Yeah.
And then we create the user, and then a lot of tests implicit the user.
Yeah.
But I mean, the user object is complicated. I mean, it's not that easy.
Yeah.
So you change the membership, and then a lot of other tests, previous written tests, is broken.
Right.
This is needed for my current test.
But you're not... So are you using the same thing across many tests? Are you running one test and the next based on the previous one?
Test is user.
Yeah.
And then implicitly we just use some user.
Yeah.
And then because it's really interesting, and you don't know why you're writing the test, and you are inheriting some class.
Yeah.
And then this user automatically given.
Right, so I think the user you generate should be... you will document exactly what the properties of that user are. So if, for example, you were doing user, you had personas, then everyone would know, because it'd be documented somewhere, that Anna is this kind of user and Bob is this kind of user. So if you then are trying to... If you then have, because the business requirement comes on that there's a different kind of user, then create a new, object mother get Anna, object mother get Bob, and then you've got this new requirement, so it could be object mother get Charlie or whatever. So if they are fundamentally different users or they're different purposes...
But it's not fundamentally different, because sometimes this kind of thing is really interesting. You don't know when it's going to break the whole other 5 tests, and this is the problem. They're really, of course, I mean, if I found out, okay, I break another 5 tests, I'm going to create a new user.
Yeah.
And sometimes then this process gets a bit tricky, and then you need to do a lot of manual work, you need to upload again the picture, and etc. So
What you can do is roll back, never commit to your transaction, so then every test starts with a fresh database.
yeah, then that will take like forever.
Yeah.
Oh, are you reusing the same data across tests? So you're not clearing out the database between
We are just loading the picture once.
at the start of the tests? Right, okay. So the problem with doing it that way is you'll run into issues like this. Is the reason you're only running it once just because it takes that long to put the data into to create the fixtures? Sorry, but we're going to have to... Can we continue this? I want to have a chat, but we're kind of at time on this. If anyone else wants to listen in, we'll just have a...